Hi guys, welcome back. In this lecture I will explain what a NoSQL database is and cover the most important characteristics of a NoSQL database. So what is a NoSQL database? It is a class of databases that have one or more of the following characteristics: non-relational, distributed data or sharding, horizontally scalable, as in we can add more hardware to increase the capacity of the database, schema free, eventual consistency, and high availability. Note that I said one or more characteristics, and I say this because no single class of NoSQL database has all of them. Most of them will have one or more of the above characteristics. Let's look at each one of them in more detail. Non-relational. If you ask me, this is perhaps the most important characteristic of a NoSQL database. Let's first see why a relational database is bad for storing big data, and then we will discuss non-relational structure. As you can see in the table on the left, relational databases normalize the data. Normalization means splitting data into multiple tables to avoid redundant data. So if I need a database to store employee information along with his or her manager information, I need a table to store employee ID and name, another table to store the manager's employee ID and name, and a third table which maps the employee ID with his or her manager ID. And if I need to show an employee's name with the manager's name, I have to do a 3-table join. The problem with this approach is that it tends to become very complicated very fast, and pretty soon you will have queries with many joins, sometimes as much as 10 or 15. These are not only complicated to write, but it will take a long time to run when there are a large number of rows. And you cannot divide the rows into multiple machines because one table might be in one machine and another table might be in another machine. That means you cannot scale horizontally as the data grows, which means you have to put everything into one machine, thus impacting availability. So you see how being relational leads to one issue after another. So in NoSQL databases like Cassandra and MongoDB, the approach was to denormalize and put all the data into one table or into one XML or JSON document, as you can see on the right side of the slide. Sure, this approach duplicates data. For example, for every employee, the manager information is duplicated. And if there are lots of employees, then it's a lot of duplicated data. But we live in a time where storage is cheap, so who cares, right? Once we eliminate the need for joins, we can not only query the data fast, but we can spread the data over many machines. The second characteristic of NoSQL database that I want to discuss is sharding. Sharding simply means distributing records over multiple rows or multiple nodes or machines. For example, let's consider an employee table that is denormalized like in the previous slide. Since the record with employee ID 1 contains all the information I need to know about an employee, I can put it on one machine, while I can put another employee's information on another machine. So the entire contents of the employee table will be equally divided among all nodes. By now it should be pretty clear that this model can scale endlessly by adding new nodes as the size of the table increases. Many leading NoSQL databases like Cassandra and Mongo employ sharding. The next characteristic I want to discuss is the horizontal scalability, which means being able to add more machines or nodes as the data grows. This is only possible because of sharding, as I discussed in my previous slide. Both these concepts go hand in hand. In fact, Cassandra's architecture allows you to add any number of nodes without impacting performance. And as you can see, Apple has over 75,000 nodes in their cluster with almost 10 petabytes of data. Next, let's look at schema-less characteristic of NoSQL databases. A schema means a predefined structure for data. This is usually in the form of a table with set column names and type of data. For example, on the left side of the slide, you can see an employee table with an ID field, which is an integer type, and a name field, which is a string or a varchar type. On the other hand, schema-less means you can store anything you want within your document. One document might have employee information, while another might have a playlist of songs. Not all NoSQL databases are schema-less. Cassandra, for example, has a preset schema which is very similar to a relational database like Oracle or MySQL. They did this to allow for a smoother transition to NoSQL for traditional relational database users. A database like MongoDB is supposed to be schemaless, but I can argue that there is an implicit schema within that document. I say this because if I am a developer passing through the document, I should know what the fields within a document stand for. Otherwise, how will I process it? So really the schema shifts from the database to the code layer. Also, if I have a table with two different documents, as in the slide, it will surely lead to erroneous processing. When I expect an employee in my code, I get a playlist. Go figure, right? The next characteristic, called eventual consistency, is something that I covered when I talked about the base property, so I won't spend much time on this. The idea here is that the database will become consistent over time. This is usually measured in milliseconds. And as I said before, some financial systems cannot deal with eventual consistency and they need immediate consistency. This does not mean that NoSQL databases cannot be immediately consistent. Cassandra, for example, provides tunable consistency where the user can tell the database what it wants through the CL parameter. The CL stands for consistency level in this regard. If you want more details on Cassandra's tunable consistency, please Google DataStax Academy, and they have a bunch of very good Cassandra tutorials starting from beginner to advanced. The last characteristic that I want to cover is called high availability. This is also something that I covered during the base discussion. The idea here is, due to replication, even if one or more nodes are down, the database is able to respond to customer queries and is considered available, provided you give the right consistency level parameter. With that, I conclude the lecture on NoSQL databases.